when is sine negative radical 3 over 2? Okay, first I think when is sine negative, right? And sine is negative in the third and fourth quadrants. Agree? Or if you did the sine charts, remember sine's the y values was positive up and negative down. Either way works. Sine is opposite over hypotenuse, right? What kind of triangles do we have there?
30, 60,
30, 60, 90, and what is this angle? 60, right? 60-degree angle. So I know it's a pi over 3 angle. In quadrant 3, what is the pi over 3 angle in quadrant 3?
4 pi
4 pi over 3. And if you want to know how we got that, this is 3 pi over 3, right? So it's one more than that. So it's 4 pi over 3. And what's the one in quadrant?
5 pi over 3.
Good. A couple ways you can think about that. It's one more after 4 pi over 3. Or it's one less than 6 pi over 3, which is 2 pi. So it's pi over 3 down. Any questions about how I got those two values? Oh, when I said from 0 to 0. So 0 to 2 pi is where we're looking. And it does say including 0, but not including 2 pi. Tangent being 1. When is tangent positive? First and third. So I'm looking at the first and third quadrant. Tangent is opposite over adjacent, right? So what kind of angle do I have?
45, 45.
Good. So 45 in quadrant 1 is pi over 4. And 45 in quadrant 3 is 5 pi over 4. How did you get that? Use the unit circle, memorize it, or this is 4 pi over 4. One more than that is 5 pi over 4. Cosine negative 1. What is cosine negative 1? Okay. Second and third is true, but I have to be careful when sine or cosine equals 1 or negative 1. Because that only happens on quadrilateral angles. So if I tried to draw a triangle, it would look a little tricky because you'd have the adjacent and hypotenuse sides both being 1, which would not really make a triangle, right? So that's why it falls on a quadrilateral angle. So only pi is the answer. Any questions about that? So those you kind of just have to have memorized. When is sine 0?
Pi over 2. 3 pi over 2.
Wait. Right, 0 and pi. Sine's the y value, so it's 0 at 0 and at pi. Now, it's also 0 at 2 pi. Why did I stop? It said not including 2 pi. So from 0 to 2 pi, not including 2 pi. We're going to be looking at doing trig functions this way today. We're going to look at inverse trig functions. You learned about inverse trig functions in geometry, but you didn't learn it well. You didn't quite know what your calculator was giving you, so that's what we'll be looking at today. Before we look at inverse trig functions, you do not have to write it all. It's stuff you learned in Algebra 2. I'm just going to do a quick review of functions and inverse functions in general to kind of put you back in that mindset of what an inverse function is. Remember, a function is one where each element of the domain pairs with exactly one element of the range. The x's don't repeat. So remember that kind of stuff from Algebra 2. So that's what a function is. And a one-to-one function is where each element of the domain pairs with one and only one member of the range. So the x's don't repeat and the y's don't repeat. And that's a one-to-one function. You learned in Algebra 2 that one-to-one functions have inverse functions. I don't know what I'm talking about. And you can tell the function function is 1-to-1 based on the horizontal line test. Well, it turns out that no trig function is 1-to-1, right? None of them pass the horizontal line test because they're periodic, right? Even tangent is periodic. So a trig function in and of itself does not have an inverse function unless you restrict the domain. And so the inverse trig functions that you have in your calculator have restricted values. They don't give you every answer. That would be impossible, wouldn't it? Because if I type sine inverse of negative radical 3/2 in my calculator is only capable of giving me one answer. Well, I know we could go on all day if I didn't restrict it from 0 to 2 pi. So we're going to have to learn today what is our calculator restricting those answers to, and that can help us find other values for t. Just another picture of horizontal line test. Inverse function of a one function switches y, switches the input and output. It's just inverse stuff. You probably have a note card on inverse functions. 1-to-1 function, each x value corresponds to one and only one y value. If the function is 1-to-1, then it has an inverse function. The domain of f is the range of f inverse and vice versa. X's and y's switch. So this is kind of some review. The graph of f and f inverse are reflections across the line y equals mx. To find an inverse, this is probably somewhere on a note card. You replace fx with y, you switch x and y, and you solve for y, and you call it f inverse. Don't remember doing that. I am solving for y. So that's how you find an inverse function. So that's inverse functions in the next one. I gave you this review just to help you understand trig inverse functions. You don't have to do any of this with trig inverse functions, but it's just to help your understanding a little bit. What you may remember from Alpha 2, and these were the problems that were really weird, and you had a couple of them, I know, because I used those same worksheets when I taught Alpha 2. Don't remember when you had to find the inverse of x squared? And it was a little weird. Or you had to find the inverse of the square root of x, and it was a little weird. Because you only had half of the parabola, and so your inverse was only half of the parabola that you got when you found the inverse, because the square root was only the top half, and so the inverse of it was only half of x squared. Don't remember that? That's why there's that weird plus minus thing when you solve equations with a square in them. You always had to do a plus minus choice. Why do you do that? Well, it's because the inverse of a square is not a perfect inverse function. It only gives you part of the answer. So some thought processes we looked at in Algebra 2. So we often restrict the domain of a function that is not 1-to-1 to make it 1-to-1 to be able to find an inverse. An example of that is x squared. When we find the inverse of x squared, you always tell me it's the square root of x, right? Those are inverses. But that's really only the inverse of half of x squared. It's only the inverse of the right-hand side of that parabola, because the square root of x does not give you any negative answers, right? So that's kind of some thought. So now we're going to look at sine inverses. We know that sine is that periodic function that goes on forever. I don't want to find an inverse for the whole thing because it would be a wave that was not a function, right, up and down the y-axis. Does that make sense? So I don't want that whole thing. I just want a piece of it. Preferably the easiest piece. That's why with x squared you do the positive side because it's easier. Positive numbers are a little easier. So we're going to pick the easiest piece of sine of x that gets us every y value. Well, I know that sine is positive up and negative down, right? So I need an answer, a section that's positive and a section that's negative. What's the easiest place to get both of those sections all in one piece? To get a positive and a negative, side by side. Wouldn't that be right here? Because otherwise, I pick 1 and 3, then I have a piece up there and then a piece some other place. So, to find sine inverse, we restrict sine of x between only negative pi over 2 and pi over 2. So, in your calculator, if you do sine inverse of a number, it's only going to give you the first or fourth quadrant answer. So try it. Do sine inverse of a half. If you want to put your calculator in degrees so you can tell what the calculator is giving you, because it does give you the decimal equivalent to pi over 6. So if you do sine inverse of a half, do you get 30 degrees or pi over 6? Do sine inverse of negative 1/2. And what do you get? Negative 30 degrees. Those are the only 2 answers your calculator can give you. Is that still helpful? It's very helpful. But you have to know that it's missing 2 answers, isn't it? Or infinitely many answers, depending on how you think about it. It's not going to give you the second and fourth quadrant answers. It's only going to give you the first, or second and third quadrant answers. It's only going to give you the first and fourth quadrant answers. So sine inverse is the inverse of a sine function. This is the graph of it. Now what you'll notice, look at these x's and y's. Have we seen that chart before? Except
It was the
the other way around, right? It looks just like the chart for sine, except the x's and y's are switched. So if you look at the graph, right, sine of, well, sine is 0 when x is 0. At pi over 2, sine is 1. And at negative pi over 2, sine is negative 1. And we can plot other points in between. That gives us our sine function. It kind of looks like it's up on its side. It is the reflection about the line y equals x. I mentioned that earlier. We drew the line y equals x and a normal sine function. You can kind of see that reflection over the line y equals x. But it's just the x's and y's switched to a sine function. So this is the graph of sine inverse of x. Notice how my x and y axes are labeled. My y-axis is now labeled with pi over 2's and negative pi over 2's, and my x-axis is now labeled negative 1 to 1. So the domain of a sine inverse function is negative 1 to 1 because that was the range of a sine function. And the range of this sine inverse function is negative pi over 2 to pi over 2. That had to be restricted, right? The range, if you looked at the entire inverse and didn't make it a function, would be all real numbers, right? Because it would wave all the way up the x-axis or the y-axis. So that range is restricted to only include negative pi over 2 to pi over 2 so that your calculator can handle it, so that your calculator can spit out one answer. So that's why we have an inverse function, and so it is restricted. For cosine inverse, let's look at the cosine chart. Cosine is positive in the first and fourth quadrants, right? So would the first and fourth quadrants give me all the answers? No, I would need one of the negative quadrants, so the ones that whoever picked to make cosine inverse a function, they chose quadrants 1 and 2. Again, that was the easiest quadrants to choose because they're side by side. So they restricted the range of cosine inverse to only go from 0 to pi. So it only will give you answers from 0 to pi. The domain is still negative 1, 1. The range is 0 to pi. So, if you didn't believe me, if your calculator is still in degrees, do cosine of 1/2. Cosine inverse of 1/2. Give you a first quadrant answer, right? Do cosine inverse of negative 1/2. So it gives you 120 degrees. Second quadrant answer. So it gives you the first quadrant answer if it's positive, it gives you the second quadrant answer if it's negative. And that is the only thing your calculator can give you because, again, your calculator can only define functions. It can't handle giving you infinitely many answers. So it's got to stop it somewhere, and so it restricts it from 0 to pi. Any questions about cosine? Do you see why they would restrict it from 0 to pi? Makes sense, right? They could have picked the third and fourth quadrants, but that would be more difficult than the first and second quadrant. Inverse tangent is a little different. They could have picked either one on tangent, agreed? Could have picked first and fourth, could have picked first and second. But the graph is prettier if they pick first and fourth, because it gets you one full tangent wave. And that way it's not broken up into two different tangent waves. So the person who picked this thought it would be nice if the graph looked pretty and wasn't two half pieces of a tangent graph. So tangent is restricted to the first and fourth quadrants as well. Its range is negative pi over 2 to pi over 2 not including, and that's because at negative pi over 2 and pi over 2, what is the value of tangent at those two things? At negative pi over 2 and pi over 2. It's undefined, right? Because that's the place where you would get a 0 in the denominator on tangent. So that's why the range stops there. The tan inverse graph has horizontal asymptotes at pi over 2 and at negative pi over 2. The vertical asymptotes just shifted around. X and Y switch. So this is a tangent inverse graph. Any questions about that? The domain is negative infinity to infinity, which makes sense. The range of tangents negative infinity to infinity, so when you switch those, the domain is negative infinity to infinity. The range is negative pi over 2 up to pi over 2, and that's because we restricted it to only the first four quadrants. You need to memorize which quadrants the answers are in. Or memorize. You need to know those. So, you can write those down really quick if you haven't already. You'll notice there are some that we didn't mention. So, sine inverse is defined in quadrants 1 and 4, from negative pi over 2 to pi over 2. And this says the same thing, so if you'd rather learn this, you can. It says the same thing, just in interval notation. Cosine inverse is defined in quadrants 1 and 2. Tangent inverse is defined in 1 and 4. We talked about all of those already. Secant inverse and cosecant inverse are defined in the same quadrants as sine and cosine, which makes sense, right? Cotangent's the weird one. It is not defined in the same quadrants as tangent because, it would split that curve up. So cotangent is defined in quadrants 1 and 2. If I were memorizing these, I might group them together. Sine, tangent, and cosecant are all defined in 1 and 4. Cosine, secant, and cotangent are all defined in 1 and 2. So you could kind of group them in threes. Somehow you need to know which quadrant of an answer to give. The reason you need to know that is I'm going to ask you to find sine inverse of a half. That doesn't give you more than one answer. So you need to know which quadrant to answer the question in. Which, if it's positive, it's easy. The answer is always in quadrant 1 if it's positive. If it's negative, it's either in quadrants 2 or 4. We just have to know which one to give the answer in. For sine and cosine, you're probably not going to mess those up because they're not positive. They're not negative. negative in the other one, like cosine's not negative in quadrant 4.
And then none of them quadrant 3.
No, none of them are quadrant 3. And the reason would be the person who did the restrictions would have probably said quadrant 3 is a little harder to get to than 1 and 2 or 1 and 4. If you think about graphing it and all those things, staying close to the origin is nice. If you look at some of the restrictions that it has up there, I'm not going to tell you necessarily to memorize those. What I mean by restrictions is like y not equaling pi over 2 and y not equaling 0. That's just because secant can't be, you can't plug pi over 2 into secant. Why not?
It's undefined.
It's undefined, and you can't plug 0 into cosecant. So that's why it's saying those aren't in the range. I don't think you'd mess that up though, because you would know that it's undefined. So, but that's why it does have those listed as can't equal. Okay. Arc sine and sine inverse mean the exact same thing. So if you ever see those words, those mean the exact same thing. Arc sine and sine inverse mean the exact same thing. They are both restricted functions. So if I want the sine inverse of radical 3 over 2, it actually becomes an easier question than the bell ringer, doesn't it? Why is it a little easier? There's only one answer, right? There's only one answer. So if I want the sine inverse of radical 3 over 2, I know I'm in quadrant 1. How do I know I'm in quadrant 1? Right, it's only defined in 1 and 4, and if it's positive, it's got to be in quadrant 1. So this is a different question than the bell ringer. The bell ringer had multiple answers. When I ask when is sine equal to radical 3 over 2, that has a bunch of answers. But when I answer sine inverse, it only has one answer. And it is 60 degrees or pi over 3, depending on if you're in degrees or radians. What about sine inverse of negative 1/2? What am I going to do? Negative, so it's in the bottom. And remember, sine's only defined in quadrant 4 for negative. So it's like the opposite over hypotenuse. That's a 30-degree. So the answer is negative pi over 6. Now, I know some of you are saying, but what about 11 pi over 6? That's equivalent, but that's not the answer sine inverse will give you. Sine inverse will give you the answer between negative pi over 2 and pi over 2. So it'll give you a negative angle in quadrant 4 or a positive angle in quadrant 4. Any questions about this? Try this. So kind of what we're getting today is a little bit of understanding of what our calculator is doing with inverse true functions. some of the same thoughts we thought in the bell ringer? Same kind of thoughts, just a little bit restricting them, but same thought process. What did we get for A? Power 2. Did everyone get power 2? Why? Well, cosine is 0 up here and down here, but when I'm doing cosine inverse, I only stay in the first and second quadrants. So, power 2. Questions about that? Cosine inverse of a half, what did we get? Over what? 3. Oops. Right, that's our sine rule. It is a 1-2 radical for you. Remember on 45 it would have to be a square root of 2 of the hypotenuse or it would be a 45, 45. So this is a radical 3 here, so that's a 60-degree angle. Any questions about that one? Inverse tangent of radical. Those mean the exact same thing. So I tried to use both so that you can get used to both. You'll see those show up here in a minute. What quadrant am I in? 1. If it were negative, where is tangent when it's negative? 4. This one is in 1. Opposite over adjacent. So it's a 60 over 3. Or 60 depending on redirections. If it tells you to write the answer in radians, do so. If it tells you degrees, do so. I'm going to work all of them in radians up here because it's the one that's a little harder on your brains. Better for you so you can practice that. Okay? Cosine inverse. Uh-oh. I just want to know, okay, so what quadrant am I in?
1.
4. Why 4?
Focusing.
It's negative, good. 1 over 4, and since it's negative, it's in 4. Cosecant is hypotenuse over opposite. The hypotenuse is negative, it's never negative. So it'll say 45, so negative pi over 4. The answer that we will be looking for is negative 45 degrees. Any questions about that? Okay. This one's interesting because it is a calculator question. These are easier by hand, a little bit, maybe a lot. So the calculator actually is the toughest question. And it asks me to find y radians if secant inverse of negative 4. How in the world am I going to type that in my calculator? And I don't even have a secant button, much less a secant inverse button. I'm going to need to think a little before I type it in my calculator.
1 over inverse of cosine? Don't just give you an error if you try 1 over cosine inverse of 4. And the reason is, if you think cosine inverse of 4, is there anywhere that cosine equals
No, so that's automatically going to pop out an error because cosine can't be 4. But can secant be 4? Yeah, right? In fact, what would cosine be if secant is negative 4?
Negative 1/4.
Negative 1/4? Do we agree?
Yeah.
So to type this in our calculator, we need to know cosine is negative 1/4. So you've got to change it in your brain to cosine in your calculator. And you got to know what the question's really asking. The question's really asking at what value, at what angle is secant negative 4, which means cosine would be negative 1/4. It does say radians, calculator is radians. What do you get?
0.82.
0.823.
1.823.
1.8. Oh. 1.8. Which is a radian value. It is bigger than pi over 2. It should be because it's in the second quadrant. Any questions? I'm going to save this one for tomorrow. I don't really spend some time on it. So we'll work out with tomorrow. We have a few more things to learn as you're oops. This is your homework. It is not due tomorrow. In fact, tomorrow. We'll go with Thursday. We'll see. I make this back to my name. But go with Thursdays now. I will also hand out your test review tomorrow. If you want it today, let me know. I can get it to you.